Hi, welcome back to My Smart Learning. Last time we looked at series circuits and today we're looking at parallel circuits. So this is really for Key Stage 4 GCSE Physics and Science, but it might be useful for Year 7s and 8s as well, working on circuits. We're looking at parallel circuits today, and our objective is what are parallel circuits and what properties do they show? What are their characteristics? Like I always like to do, I like to start off with a quick recall PT quiz. I call it high five because I only ask you 5 questions, and if you get them all right, you get a virtual high five from me. So what do you remember from last time? Recall quiz. Right, what happens to current in a series circuit? So what was the conclusion we drew from our last video? What happens to current in a series circuit? Question 2. What happens to the voltage in a series circuit? Question 3. What happens to resistance in a series circuit? Question 4. Q equals, what's the formula for that? Q equals. And question 5, V equals. So, if you press pause, have a quick go, check your answers, make sure you got them right or as best you can. And I'm going to go through the answers now. So first one, current in series. So the conclusion we drew from the last video, current in series is the same at every point around a series circuit. So if it's 2 amps there, it'll be 2 amps there, 2 amps there, 2 amps there, all the way around. What about voltage though? Question 2, the voltage is actually shared. The voltage is shared amongst the components in a series circuit. So for instance, if the battery had 6 volts and had 2 bulbs in there, each bulb would get, if they're the same bulbs, each bulb will get 3 volts and 3 volts. Resistance in series, how do I calculate that? Well, RT, the total resistance, is equal to R1 plus R2 and so on and so on and so on. So the total resistance is you just keep adding up all the resistors and you'll get the total resistance. Simples, right. And number 4, Q equals IT. Q equals IT. The charge, which is measured in coulombs, is the current measured in amps times the time, which is measured in seconds. Remember, coulombs for charge, current is in amps, time must be converted into seconds. So if you had 1 minute, it would be 60 seconds, 5 minutes would be 300 seconds, and so on and so on. And V equals, Ohm's law, V equals IR. Voltage or potential difference is measured in volts. I is current in amps, and R is your resistance measured in ohms, and that symbol is omega, that little horseshoe type shape. So V equals IR. If you got those all correct, excellent, well done, you're remembering your stuff, that's fantastic. You get a virtual high five from me. Now, parallel circuits then. What are parallel circuits? A parallel circuit is just like a series circuit, but you get branches. You get extra circuits attached on top of the circuit. So if you imagine I built a normal series circuit like this, if I got my leads, if you remember, the leads will be there, we're going into the bulb there. There'll be 2 little holes on top of those leads there. If I get extra leads and I plug it directly into that bulb and make another loop, another branch, that's a parallel circuit. It makes like a figure of 8 shape like this. And I can keep doing that and keep adding extra bulbs or components. A parallel circuit is just a circuit with extra branches attached directly to the original circuit there. And I can keep doing that over and over again. Now, I didn't actually mention this last time. There's advantages and disadvantages to series and parallel circuits. A series circuit has more disadvantages. Is if you switch it on and off, then everything in that circuit will be on and off at the same time. So that's a disadvantage because everything's controlled by one thing. And if it's a string of bulbs, if one of those bulbs breaks, all of them go out, which is not good. So if you had like the old-fashioned Christmas lights, if one of them went, you wouldn't know which one it was that would blown. To check every single one to find out where the problem is. Now we don't use those now because obviously it's no good because one goes, all goes. But with parallel circuits, if one goes, that will still work because there's still a route for the current to flow around. And I can also control those bulbs individually. If I had a switch on each of those branches, I can control those individually. So in your house, you have parallel circuits, not series circuits. Because for instance, if you're in one room reading a book and somebody else in another room and they decide to switch the lights off, all the lights in the whole house will go off at the same time if we were on a series circuit. So that's no good. You want to be a parallel circuit because you've got individual control of the individual small localized circuits. So the thing with a parallel circuit though is that all of the energy will go to all of the bulbs. So if you're built on a cell or battery, the battery will drain much, much faster. Whereas the advantage of a series circuit in this sense though, is that although if you keep adding bulbs, each bulb becomes dimmer, so that's a disadvantage, whereas here they'll all stay bright. The advantage of a series circuit is that battery would last longer because it's sharing the energy out equally amongst each of those components. They'll be dim, but the battery would last longer. Whereas in a parallel circuit, each of the bulbs will get all of the energy, and therefore that's why they stay bright, but they use up that energy quicker, so that battery will go flatter quicker. However, most parallel circuits aren't using cells. We tend to be plugged into the mains, so you're not really worried about how quickly the energy is getting used up. You just got a bill to pay at the end of the month. Okay, so what we're focusing though is what happens to the current at different points on a parallel circuit, and what happens to the voltage or the potential difference at different parts in a parallel circuit. So we're going to measure the current there, so that'll be our position 1. We're going to measure it here in position 2, here at position 3, and we're going to measure it here at position 4. So we've got our starting point anywhere along here, position 1, 2, 3 and 4. And with our voltmeter, we can measure the potential difference across the cell, the battery there, and we're going to measure it across each of the components. So we're going to measure it there, and we're going to measure it there. So that'll be your V1, V2, V3. So results table could look something like that. So I have my 4 positions of my ammeter, and then my voltmeter was in those positions there. So what would I get? Now, based on this diagram here, the current you'll see will split. We'll look at that in a second. But with the voltmeter, if I've got 6 volts there, that that resistor there would also get 6 volts. And this one there would also get 6 volts. So that's what would happen in my results table there. I'd get 6, 6, 6. Don't know the devil's number, but that's how it's worked out. And then the current will start off, if let's say I had, I'll go back a notch, if I had, let's say I had 4 amps there. If I had 4 amps there, what would happen in position 1? You'd get 2 of them going down there, that would become 2 amps. I'd have 2 of them going down there with 2 amps, and then they'll join back together again, there being 4 amps. So in my results table, I'd get 4, 2, 2, 4. So what does this all mean? So 2 rules that we need to know then about parallel circuits. In a parallel circuit, the current has when it says choice, it doesn't mean it doesn't choose which way to go, but it's got 2 pathways it can go, 2 routes. So in this particular parallel circuit, if it starts off here and it comes down here, then some of it can go there, some of it can go there. And it just depends on how many components you've got. So if you've got 2 components on each of those branches, and they're the same resistance of each of those branches, half of it will go there, and the other half of it will go there. But eventually, they'll join back up there, because there's a junction there, so they'll join back up there together again. Whereas if I've got 3 branches, so if I've got 6 amps here, what would happen if these guys have got the same resistance, because the bulbs are exactly the same, what would happen is that if I've got 6, then that means I should get 2 going through that one, I should get 2 going through that one, and I should get 2 going through that one. Eventually they should join back up together again. I should get 4 there, I should get 6 there. It's a bit like, let's say you're in the park with 6 friends, or the 6 of you, and you're walking along in the path, and then you get lost, and then you see it bridging off, and you decide, okay, some of us will go that way, some of us will go that way. So 4 friends carrying on that way, 2 friends carrying on that way. Then we come across another junction, 2 more friends go that way, the other 2 friends go that way. Eventually these paths meet back up together again. Those 2 friends and 2 friends meet up here again, they're 4 friends. And then eventually those 2 friends will meet back up together again. And you end up with 6 friends in total there. Well, luckily for you, you've got 5 friends because there's 6 of you. Anyhow, you'll go back to the original space. So that's what's happening in a parallel circuit. The current is split at different junctions. And that's different to a series circuit, remember. In a series circuit, it's the same at every single point, no matter what. But in a parallel circuit, the current splits at the junctions. So the conclusion then, if I had 2 branches, like from my first slide, the current at the first position, I1, was the same because they were split, remember? So the total of the two ammeters, ammeter 2 and ammeter 3, if I add those two together, it makes the same as what it started off with, and it's the same because they all join back together again at the end. So you might want to make a note of that. So current in parallel is the same as I1 is equal to I2 plus I3, so the branches are, which is equal to I4. What about, okay, some questions then, some example questions. So for instance here, you might want to pause the video and see if you can work out what the current will be at the different points along the two different parallel circuits. If you press pause, have a go at, sketch them out, see if you can label what the current will be there, there, and there. And same thing for here, what will it be there, and then there. This one's a bit of a trickier one, that one should be quite straightforward. Pause the video and have a go. Okay, so if you've had a go at that, this one should be straightforward. If you've got 3 amps going on there, then again you've got there's three of you, three friends walking together, suddenly it splits off. One of them will go that way, so you get 1 amp reading there, 2 people carry on, you'll get a 2 amp reading there, then you get another junction there, you'd get another 1 amp reading there, and then there's only one person left, so you get 1 amp reading there, so there'll be 1 amp there, so you've got 1 amp there, 1 amp there, 1 amp there. Now those two branches come back together again, so I'll end up with 2 amps there, and then eventually that junction joins on together again, so I'll get 3 amps there and back to the normal. So that one should be quite straightforward, it keeps splitting off. This one is a little bit trickier because it's not the same at each branch. I've got 1 bulb there and I've got 2 bulbs there, which means there's more resistance on this one and less resistance on this one, because the resistance is something trying to slow down or stop the current. So here the bulb is trying to slow down the current. So I've got more resistance, less resistance. So I should get less resistance, I should get more current on that one, and I should get less current on that one. But how do I work out how much? Well, it's all to do with ratios here. The resistance on this one is going to be half the resistance of this one. So this one's got double the resistance of that one. So the best way to do it is do it in ratios. Well, how many things have I got in total? Well, I've got 3 things in total. So if you can think about two-way ratios here, two-way ratios would be, I do 6 divided by, well, there's 3 things in total. 6 divided by 3 gives me 2. So one part of this current is going to be 2. And then to work out what the other part is, I'm going to multiply by what the bigger number is, which is 2. So 2 times 2 is 4. So my 2 currents are going to be 2 amps and 4 amps. Well, which ones will get which? Well, the 2 amps will go through this branch and the 4 amps will go through this branch. Why? Well, this has got less resistance, so you'll have more of the current, so 4 amps is more. And this one has got more of the, so this has got less of the resistance, this one's got more of the resistance, so this one will get my lower current, so this one will get 2 amps. So 2 amps will flow through there, and 4 amps will flow through there. So if I got my ammeter, put it there, it would read 2 amps and 2 amps, sorry, it would read 4 amps there and 4 amps there, and here it would read 2 amps, 2 amps, 2 amps, 2 amps there, but then eventually join back together again, and I'd get 6 amps there. So that's a little bit of a trickier one. There'll be some more tricky questions coming up. What about voltage in parallel? So if I get my circuit, I can have bulbs, I can have resistors, I can measure the voltage across my cells or my batteries, I can measure it across this voltmeter, this resistor, or I can measure it against this one. So this is just showing me I'm measuring across this particular resistor there. I could do it just across this particular resistor there. I could do it just to get across this battery there. And what you'll notice is this, is that the voltage, so you might want to write this down because it's a key point, the voltage in parallel is the same at every single branch, no matter how many branches I have. So the V total is the same across the first branch, same across the second branch, same across the third branch. So it doesn't matter what. So if you imagine that was 6 volts, like on the previous slide, 6 volts there, you get 6 volts across there, you get 6 volts across there, and if I keep adding on more and more branches, I'd still get 6 volts across every single branch. So that's the next conclusion. The total voltage is the same at every single branch. What about the resistance? Now, this one is a bit trickier. Now, at GCSE, all you need to know simply is this, that the total resistance is less than the smallest resistor. which sounds a bit weird. So if I go back to this slide here, so imagine I've got two different resistors. Let's say this one was 10 ohms and this one was 5 ohms in resistance. Well, the total resistance will be less than that smallest one. Now, if that's 5 ohms, you'd get something as a total less than 5. So it might be 4 or 3 or 2 or whatever, okay? So it's going to be less than the lowest resistance. That's all you need to know for GCSE. If you're thinking of studying this at A level, it used to be in the old GCSEs, when I studied GCSEs a long time ago, we had to learn this formula. And in A level physics, you need to know this formula. The total resistance in a parallel circuit is 1 over R1 plus 1 over R2 and so on and so on and so on. But you'd have to actually do 1 over R there. So it would be the reciprocal of that. So something I missed out there. I can amend it now quickly. So you'd get 1 over R1, 1 over RT. So it'd be 1 over amending it as we go along. Let's make it a bit smaller so it all fits on. So you've got, this is for if you want to do A levels. So if you want to do A levels, you'd have to know that 1 over R total is equal to 1 over R1 plus 1 over R2, and if you've got more and more resistors, you keep doing 1 over R3, 1 over R4, and so on and so on. So that would be to calculate the total resistance in a parallel circuit. But you don't need to worry about that unless you're thinking about doing A-level physics. At GCSE level, all you need to worry about is that the total resistance is less than the smallest resistance. So it becomes less. So the more resistors I keep adding in parallel, the total resistance actually gets less and less and less and less. So here's some example questions then. So this is a bit tricky now. You might want to press pause and see if you can work out what the answers are to A1, A2, A3, V1, V2 and V3. So pause the video, sketch out this diagram and see if you can work out what the answers to those particular questions are. So if I give you a minute. So if you press pause, if you come back from the pause, these are going to get quite tricky. Okay, so we've done the basic ones. So I've got 6 volts here across the battery there. So each whole branch is going to get 6 volts as well. So this branch here in my parallel circuit, well, this must be the same as that. So that's going to be 6 volts too. So V1 equals 6 volts. What about V2 and V3? Well, there's 2 bulbs there. The entire branch there, the whole branch there, would also get 6 volts. But what will it's shared out equally because these bulbs are exactly the same. So that one will get 3 volts and this one will get 3 volts. So 6 volts on that one, V2 will be 3 volts and V3 will be 3 volts. What about the current though? So based on what we've just done about this sharing it out, so if I've got 3 amps there, it's also going to be 3 amps there because it's coming across there and it all joins back together again. That's going to be 3 amps there as well. So this is just like a normal parallel circuit. This is the end of it where it goes back to the battery. These are my 2 branches. Well, this branch has only got 1 bulb, this branch has got 2 bulbs. This one is going to have more current, and this one is going to have less current because it's got more resistance because there's more bulbs there. Why? So how I'm going to work this out? Well, I'll do it in ratios. There's 3 bulbs there. So I'm going to do 3 divided by 3, which gives me what one portion is. So that's 1. And then that 1 times 2 gives me 2. So my 2 answers are 1 amp and 2 amps. Which goes where? Well, the 1 amp goes to where there's more bulbs because it's going to have less current flowing through there. So this one is going to be 1 amp and A1 is going to be 2 amps. So this one's going to have more current flowing through it. So it's going to be 2 amps and 1 amps there. And then this one is going to be what we all started off with, 3 amps. Okay, so 2 people walking through there, 1 person walking through there, eventually join back up together again. Let's go on to some harder questions then. What about this one? Similar kind of diagram, a little bit trickier. So this will be more of a sort of grade 7 plus question. You can pause the video and have a go. And then I'll go through the answers now. So you've got 10 volts across this battery, which means the entire branch, this branch here, will also get 10 volts. And this whole branch will also get 10 volts. So each bulb will get different amounts. So if that's 10 volts in total, that means each one will be 10 divided by 3. So each one will have 3.3 recurring, 3.3 recurring, 3.3 recurring. So well, I've got this voltmeter across two of them. So it's 3.3 recurring plus 3.3 recurring. So it will be, so V1 would read 6.6 recurring. Or if I rounded it, it would be 6.67 volts. And what about these two guys? Well, this whole branch, remember, has got 10 volts, which means that one is shaded out equally because it's got two bulbs. So that's going to be 5 volts. So V2 will be 5 volts and V3 will also be 5 volts. So that one, V1 is 6.6 recurring or 6.67 volts, 5 volts for V2 and 5 volts for V3. What about current? A little bit trickier now. Current, as it goes through there, it's got 3 amps. But now I've got 5 bulbs in total. So I need to do 3 divided by 5. Okay, so it's 3 over 5, 3 divided by 5. And then I'm going to multiply it by my two numbers. I'm going to multiply it by 2 and I'm going to multiply it by 3. So if I do 3 over 5, which is 0.6, times by 2, so I'm going to get 1.2, so 0.6 times 2 is 1.2. So one of my results is 1.2. If I do 0.6 times 3, it's 1.8. So my two numbers are 1.2 and 1.8. Do you like that maths? All done in my head there. Right, so 1.2 and 1.8. So 1.2 is one of them and 1.8 is one of them. Well, which one's going to go where? The one that's got more bulbs will have less of the current going through because it's got more resistance. So through this one, I'll get my 1.2. And through this one, I'll get my 1.8. So this one will read 1.2 amps. And this one will read 1.8 amps. That's got more current because there's less resistance, there's fewer bulbs. So it's going to join back together then. This one would read the same as that one, 3 amps, because it's all joined back together again. That's a particularly tricky question. Okay, using Ohm's law then. Using Ohm's law, can I calculate this question? Right, so if I've got an ammeter, this is a series circuit then. I've got an ammeter measuring 2 amps there. I've got a voltmeter reading 10 volts there. Well, if that's reading 10 volts, and these are equal bulbs, that means that must be reading 10 volts. That must be reading 10 volts. That means the entire thing must be reading 30 volts. What is the resistance across this bulb? Well, remember the resistance? V equals IR. Remember the starter? V equals IR. So voltage is current times resistance. Therefore, if I rearrange it, remember my formula triangle, V is at the top, IR. So I'll cover up the R. It's V over I. So the voltage divided by the current gives me the resistance. The voltage divided by the current gives me the resistance. So resistance is voltage divided by the current. So it's 10 divided by 2, which equals 5. High 5. So 5, what's the resistance across this bulb? It's 5 ohms. Now assuming that all the bulbs are the same, what's the total resistance? Now remember in series circuit from our previous lesson, RT is equal to R1 plus R2 and so on and so on. Well, if that's 5 ohms, and that's 5 ohms, and that's 5 ohms, it's going to be 5 plus 5 plus 5. So the answer to question 2 is 15 ohms. So what have we learned over the last 2 lessons? Series circuits and parallel circuits. Actually, we'll do a couple of quick more questions, some trickier ones. So how do I work out the resistance of these particular bulbs? Remember, resistance is voltage divided by current. There's the volts, there's the current. 12 divided by 3, that bulb will be 4 ohms. 4 ohms, and if they're all the same, it would be 4 ohms, 4 ohms, 4 ohms. That would be, in total resistance, 12 ohms. What about this one here? So this one, again, remember resistance is the voltage divided by the current. Well, what do I know about parallel circuits? Well, parallel circuits, the voltage is the same at every single branch. Because look, the reading's up here, not here. It's asking me about the resistance of this bulb. Well, if that's 6 volts, then that must be 6 volts, and that must be 6 volts. So this, in total, must be 6 volts here across this bulb. There's the current, 3 amps. Resistance is the voltage divided by the current, so it's 6 divided by 3. The resistance of that one must be 2 ohms. So the bulb resistance there is 2 ohms. What about this one here? Okay, so we'll have to look at the clues in the question. The clues in the questions are this. There's one bulb in this branch, and that bulb reads 4 volts. So if there's 4 volts there, that means this cell or this battery of cells here, that must be 4 volts. And this entire branch must be 4 volts as well, because each branch is 4 volts. And if that one's reading 2 volts, then whatever's left over must be this one as well. So that one must also be 2 volts. These bulbs must be exactly the same. So that's 2 volts. Therefore, this bulb must be 2 volts, because 2 plus 2 makes 4. So that's 2 volts there. The current is 1 amps, and we want to know the resistance of that bulb. And the resistance is the voltage divided by the current. The voltage is 2, divided by the current, which is 1. 2 divided by 1 equals 2. So the resistance of that bulb is also 2 ohms. So to finish off, to summarize these last 2 lessons, what have we learned? We've learned about series circuits. And these are the 3 rules. You must memorize these 3 rules about how series circuits work. In the series circuit, the current is the same at any point, all the way around. 2, the voltage is split up over each component. Remember, so you've got 6 volts across the battery, and there's 2 bulbs, it'll be 3 volts and 3 volts. It gets split up, and that's why the bulbs get dimmer. And the last thing, how do I work out the resistance? You add them up. So in a series circuit, you just add up all the resistors, or the resistance of each of the components. And the last thing to finish off are parallel circuits then. What have we learned about parallel circuits? The current splits up down each strand or each branch. Okay, it splits at the branches, and you need to know exactly how they split up. But the voltage stays the same across each strand or each branch. Okay, it's the same at each branch. And the resistance decreases the more branches you have. The more branches we have, the resistance keeps decreasing, and it's going to be less than the smallest resistor. Whatever's the smallest resistor on your circuit, it's going to be less than that. And that's what you sort of need to know for GCSE. Remember, if you want to go into A-levels, you need to be able to calculate it. So I hope that's been useful. We've gone over series circuits and parallel circuits. Make sure you're using your revision guide. Use the BBC Bite-Size website. Use your Caboodle textbook. On Show My Homework, I'll be referencing the right pages to use to be making notes on those and answering the questions, because that's what you've been doing if you're in school anyway. And I hope this has been useful and you've learned something about series and parallel circuits. Please make sure you watch all the videos, you like them, you subscribe to them, and make sure you share them with everybody else. Stay safe, keep well, and hopefully we'll see you guys back at school as soon as possible. Take care and see you on the next video.